By Malachy entitled Achieving Sustainable High-Performance Buildings Through Knowledge-Based Building Information Modelling Systems. Malachy is currently a lecturer in the Department of Architectural Technology in Bolton Street, DIT. He has previously worked with Fingal County Council, and I can absolutely attest to the fact that he is an active advocate for the advantages of BIM and computer design applications.
Thank you. Was anybody in the O2 last night? I see one or two heads nodding there. Roger Waters performed The Wall, and I went along expecting to see a musical gig, but was treated to a theatrical extravaganza. Extraordinary to see a collaboration of musicians, artists, sound engineers, pyromaniacs, that's what I call them, video technicians, stagehands, structural engineers, riggers, puppeteers, all collaborating to realise the vision of one man, Roger Waters. It happens in other businesses, folks. I wonder if could it happen in the AEC business. There they are this morning, packing up to go and bring that show off to another stage and be faced with new problems, smaller stages, higher stages, things like that. But you'd be guaranteed they'll put that together and do a fabulous job on it. Alan's asked me to speak today on achieving sustainable high-performance buildings through knowledge-based building information systems. Could have made that a little bit more sharp, I think, but allowed me a little bit of flexibility in the presentation as well, I think. Folks, if we need a justification for the changes that need to happen in the way we conduct our business in the architecture, engineering, construction industry, and how we reflect this back into the education of our students, it's simple. It's climate change. Kyoto protocols and the later protocols are starting to drip feed now down into and affect us in our business. Recasting of the Energy Directive from the EU, updating technical guidance documents Part L, all making our business extremely complicated, but having a direct effect on how we go about our business. Chris Hume is Secretary of State for climate change in the United States, and he says climate change is the greatest threat to our common future. And we have a very short period of time to tackle the problem before it becomes irreversible and out of control. We work in an industry that can make a significant contribution to reversing climate change. Educational institutions need to have a high priority goal to provide to industry a workforce that can design and construct green, sustainable and high performance buildings. The AEC industry needs to design and build more efficient, easier to run buildings that reduce an impact on the environment. We need to embed in our education a holistic methodology for designing sustainable buildings to minimize their environmental impact. This presents a challenge to the pedagogy by which we educate our students, and it presents a challenge in industry. That challenge in industry needs to be reflected back into the education of future graduates. In industry, the current disconnected linear design process is a model of inefficient practices. The first time the whole design construction team assembles is generally at the first site meeting where the fun starts. And the fax machine becomes a predominant electronic device as it transmits the daily ORFIs. Any of us who have worked in construction know exactly what I'm talking about there. This linear process will have to change. And to do this, we face a major challenge. We operate in a system of hierarchy. The designers at the top, technical people in the middle, and the contractors left to put it all together and build it. This is where BIM technologies and methodologies come into their own. The old hierarchies get moved aside. The linear design process gets binned in favor of a circular or elliptical design process where designers and technical professionals collaborate around the digital model. each bringing their own skills to the process in real time, and that's different. It's a bit of a utopian diagram, to be honest with you. To achieve that is going to take an incredible change of mindset, and perhaps that's the most difficult thing to achieve. Through my research over the last number of years, I've found that roles are blurring in the business. If I go back to that diagram, my colleague in DIT, Dr. Ken Beattie, who's involved in building services, will say, when it comes to the design of a building, why am I so far down the line? By the time I get the building, I can't influence the changes that need to happen in order to make this a more efficient building. Instead of being down the line, I want to be at the table, at the design. So I can bring my expertise in regards to simulation of options in order to give us a more efficient building. But if I'm too far down the line, I can't do that. Come back to this diagram of people operating and contributing to the model and then taking data out of the model. It allows for that process to happen. It allows for people with these skills to be able to influence the design for a more complete, holistic and sustainable product. In the concept, scheme and detailed design, we need to look at strategies. And this is a word that is going to become very familiar to you people in the business. Strategies for energy, strategies for solar, for light, building matrix, egress, water, airflow, fluid dynamics, system renewables, thermal comfort levels, sustainability compliance, value and cost and carbon footprint. To achieve a holistic, sustainable design, I wonder, is there a case for what I call performative architecture? And that is architecture that's based not on the form of the building, but the function of the building, and the selection of materials influencing the function of the building. There's a couple of examples of buildings I want to bring to you. Out in the City West, out that direction, I think you know there's an extraordinary building out there with an enormous glass facade on it, processing plant for printing, newspaper printing. If I ask you the question, was that building built for function, or was it built as a corporate statement? I wonder, what would you think? You're driving kind of east to west. The building is prominently situated so that when you're driving, everybody sees this building. It's got an enormous glass facade on it. It's got all the manufacturing of the processing plant in behind it. During the summer, when you get a hot summer, solar radiation elevates the heating in that building to a point that the ink doesn't stick on the paper. Built for corporate identity rather than for function, in my opinion. Another building that I worked in the new Fingal County Hall out in Swords, a very, very modern building, and the architect had a fantastic attempt at bringing in sustainable technologies into the building. I worked in one of the wings up on the top floor, and natural ventilation was designed into that building rather than mechanical systems. There are mechanical systems within the core areas, all right, but the idea was to get natural ventilation going through the building. So each person in their workstation has a window which they can open up or close in order to let the natural ventilation in. Fantastic in the summer. During the winter, the staff feel drafts, so they come up with a very technical solution in order to stop those drafts. They take out sellotape and they sellotape all the joints. So the theory was excellent, but the technical design didn't follow through on that. in that the joints weren't strong enough to contain the kind of pressures that the wind put onto the building and put onto the facades when you're in an enclosed area. And perhaps a bit more analysis and a bit more simulation might have highlighted a problem like that, and a more deeper and more technical solution could have happened. Modern building is getting very complicated, and no one profession holds all the answers to the questions. The IPCC is the International Panel for Climate Change. In a report in 2007, they said an integrated design approach is required to ensure that architectural elements and engineering systems work effectively together. So perhaps a proactive step in achieving sustainable high-performance buildings through knowledge-based building information systems is to realign the design team based around a collaborative, integrated design methodology. BIM technologies provide the robust platform through its centrally located digital model and electronic collaborative methods to do this. New building design and existing building retrofit can be analysed at both a macro and a micro scale using dynamic simulation methods. Now folks, this is something we're going to have to face up to in order to for buildings to comply with new Part L regulations. We're going to have to go in and do this. You can sit down and work this out on a calculation basis, or you can go in and you can use dynamic simulation methods. We need to be able to measure what the changes are. If you can't measure it, you can't improve it. We want to be informed to develop strategies that will work for the climate, for the site, and for the buildings in question. That diagram on my left-hand side there is a 3D simulation carried out by one of my students in regards to an investigation in thermal bridging. This is as part of his research dissertation this year. But the advantage of doing this in 3D as against a flat 2D section is that he's pinpointed where the problem of thermal transmittance occurs, and it occurs in the corner, right in the corner. Now he wouldn't have been able to get that far unless he was able to do this in 3 dimensions. Burt Hill are a US-based architecture and engineering consultancy. They have an in-house team dedicated to building simulation, and Dustin Epley is the leader of their energy analysis team, and he's quoted as saying, "When the architectural design model is also the energy model, energy modeling and responsiveness become core components of the design process. For example, rooms designed explicitly as 3D engineering consuming volumes instead of just floor space bounded by walls." This is thinking going beyond just form architecture. This is function architecture. I want to give you a flavour of the dissertations that fourth-year architectural technology students have done this year. And I really feel that these students are pushing the envelope in regards to analysis and simulation. These are the range of softwares that they're using. I'm sure you're familiar with a lot of them. IES, Don McLean's software developed over in Glasgow, can be used on a macro and micro level for analysis of solar energy compliance, daylight, CFDs and mechanical. WFI is a German software used on a micro level, and one of the students is doing his dissertation on vapor diffusion and liquid transfer in building materials. INSUL is a predicted sound insulation performance, so it involves acoustics and the acoustics of materials and how materials affect acoustics. Deep 3 you're more than likely familiar with. That's our Part L base standard. Antherm is the 3D heat transfer through building materials. That's what the student used in that illustration I showed you. Therm 5.2 is the 2D version of Antherm. Ecotech is now an Autodesk product, and again is a whole energy analytical software for energy, solar, daylight, thermal, water, shadows and reflection. And Radiance is an analysis of lighting for design. Don McLean in Glasgow says that performance analysis is a vital component in designing truly sustainable buildings. I'd say that predictive analysis is set to become an integral part of building design and retrofit. I know that local authorities are under severe pressure in the next decade. All of their building stock, their housing stock, their commercial stock, their civic stock has to be brought up to meet the demands of the TGL documents. So all those community housing that you see, each one of those has to be looked at on an individual basis, and what strategies are they going to formulate for that building to meet the Part L requirements. In order to test options and strategies, they're going to need to run simulation. And if they don't have that expertise in-house, they're going to have to look outside for that expertise. There is enormous potential there. Retrofit is the name of the game in Ireland for the next 10 years. We've been told to do it, we've been directed to do it by the EU, there's no choice, we have to do it. Where we're going to find the money to do it, another problem maybe, but this is something we have to achieve. So if I was in business, things like BIM technologies are things I'd be looking at. I see the future of practice changing. No longer are you going to have, in my opinion, the firm of architects in Marion Square, the firm of engineers in Harold's Cross, the mechanical and electrical guys in Fairview, all coming to site and meeting there. To me, the smart guys in practice are going to set up cooperative pods of interdisciplinary practices. How it's set up is their business, whether they are collaborative or whether they're partnerships. I'm not concerned with that. What I am saying is that to be able to offer to the likes of Dublin City Council and local authorities, other local authorities, this kind of service. Cradle to the grave was mentioned earlier, but included in that service, that kind of analytical simulation based on options, I think is a huge prospect and a huge possibility for our depressed industry at the moment. So what I'm saying is that within the one office, we'll have possibly the architect. You will have the architectural technologist. You will have the building services engineer. You will have the civil engineer. All contributing their skills in order to give you a holistic design and service that can be put out there. One of the only advantage possibly that I can see in this downturn is that it affords us an opportunity to reassess how we've done our business in the last 10, 15 years. And if you want to be truthful about it, it's not been hugely efficient the way you've gone about it. There is a chance now to readdress that. And the platform is here now. The platform is BIM. A selection of the dissertations from the fourth-year architectural technologists. Predictive modelling of heat transfer and thermal bridging within the building envelope. The reduction of energy demand and CO2 emissions at First Royal Court, a Dublin City Council senior citizens complex. Material selection for healthy building design. Formaldehyde emissions within building materials. Investigation into window thermal performance. Using these analytical softwares, we can actually see where the heat is leaking out. You can compare aluminium windows to timber windows to PVC windows and actually have data in front of you that will allow you to choose the correct solution, the correct strategy. Critical appraisal of BIM and integrated environmental analysis in performing energy assessment on building design. There's another one that I don't have here, but I was talking to one of my colleagues there this morning about it. And what this student has done is he's taken one of those shell buildings, like the Anglo building that's out down by the docks there, which is a concrete core at the moment. That's been sitting there for a couple of years. So how do the new regulations impact on that building? And what changes do you need to do in order to make that comply with Part L? And that building has an enormous amount of glazing in it. Now, 3 years ago, that might have been fine. Now it's not, because the pressure that Part L, the requirements of Part L put on glazing is such that you need to go into very expensive glazing in order to conform to Part L. So there's a new strategy required for that. So wouldn't it be nice to model that up in BIM and run options on it, run strategies on it for glazing, and possibly even now cladding it, recladding it, taking an amount of the glazing out and recladding it with solid cladding or something like that. Okay, you have to go for a new permission on it, but you know, a new permission waiting another, whatever it might be, a couple of months or something like that, against a possible bill of $250,000 in order to put the glazing in. It makes sense to me. A hydrothermal analysis of timber frame construction in the Irish climate. We have an exhibition of students' work that's open from Friday the 10th of June for 2 weeks. I would encourage you all to go along and have a look at that. It's in the 4th floor in DIT. And you'll see real life examples of this analysis going on. Carbon neutral cannot be achieved without the highest level of early and continued cooperation amongst the client architect and the engineers. Again, my colleague, Dr. Ken Beattie, is fond of asking this question. I'd like to ask it here. How many people does it take to do a building information model, to run an analysis, to run options on that analysis? Are we saying 3 people? Building services engineer, technologist, architect? Who would say 3? Who would say 2? Who would say 1 person could do all of that? That's the majority view. That's interesting, isn't it? That's what I mean about the blurring of accepted roles, of traditional roles. Now I know this architect's going to go, what are you talking about? I'm not going to let any building services engineer affect my design. Why should I do that? Well, there's the challenge for the architect straight away, because that's going to have to happen. I know the services engineer are going to stand up. I'm not going to let the architectural technologist do my job. But isn't it interesting that building services contractors get paid for the amount of plant they put into a building, while we're trying to design the plant out of it? There's a challenge. Each of these challenges is discipline specific, and you face, in your own discipline, you face your own challenges. But it comes together under the umbrella of collaboration, and you are going to see blurring of roles, there's no doubt about it. Architects using simulation, architects can get quick environmental feedback on their design iterations, and environmental engineers can input more into the design. That's Ken Beattie's dream. It's his dream for his students as well. Achieving this kind of effective collaboration and cross-disciplinary understanding is, in my opinion, the core to achieving truly sustainable, energy-efficient building design. Government are announcing today the LMA funding. And the Department of Architectural Technology has been awarded LMA funding for a postgraduate certificate in digital analysis and retrofit. This might be of interest to you or some of your colleagues. This PG Cert in digital analysis and retrofit is a 30 ECT credit program. It'll be a part-time program which has been designed to enable architects and architectural technologists to develop skills centered on digital analysis, energy performance and retrofitting of existing buildings through the medium of building information modeling. If you keep your eyes out for that, that is, that I understand is being announced today. 2 diagrams I want to bring your attention to here. That's a thermal imaging map of your typical balcony that you get in a apartment building. And you can see the amount of energy, heating energy leaking out through, is the connection back into the structure, which is taking the heating energy and bringing it out. This is one of the thesis dissertations done this year, in which the student has actually calculated the amount of energy that flows through the reinforcement and through the steel, coming from the building out through to the external balcony, and a possible method of how to, not a possible, but a proven and analytically worked out method of preventing that. I think that gives you a flavour, and I have the benefit of being in academia, so I can throw out challenges very easily like that. You're the guys in practice, and you're the guys who have to face up to that. Thank you.
Again, just following the same process, does anybody have any immediate question that you want to ask Malachy? Okay, Malachy, thank you.